Hello, in this video we will learn how to solve rational equations. So the first question is 3x over x plus 2 minus 1 over x equal to 0. As you can see that in this question we have two different denominators, x plus 2 in this case and x in this case. So we need to find the least common denominator. So in other words, we need to find the LCM of x plus 2 and x. So the LCM of x plus 2 and x is x multiplied with x plus 2. So once we have this as the denominator for both of them, then we can add the numerators or subtract the numerators. So let's rewrite this equation. So 3x over x plus 2, and we need to multiply the denominator by x, so we need to multiply the numerator by x as well, minus 1 over x. This needs to become x times x plus 2, so therefore we need to multiply the numerator by x plus 2 also, and that's equal to 0. Now that the denominators are the same, we can rewrite this equation as x plus 2 in the denominator times x, and in the numerator we will have 3x squared minus x plus 2 equal to 0. So now what we can do, 0 is basically 0 over 1. We can cross multiply, and therefore we get 3x squared minus x plus 2 multiplied by 1, and that's equal to x times x plus 2 multiplied with 0, which will get us 3x squared minus x plus 2 equal to 0. So therefore we have 3x squared minus x minus 2 equal to 0. Now we have a quadratic equation, and we just need to find the roots of this equation. So we can factorize this as follows: 3x squared minus 3x plus 2x minus 2 equal to 0. In the first two, we can take 3x as the greatest common factor, and that will be equal to x minus 1 inside the parenthesis. And then in the next two, we can take 2 as the greatest common factor, and then we'll have x minus 1 in the parenthesis. So that's equal to 0. So now in this and in this, as you can see, the greatest common factor is x minus 1. So we can pull that out, and then what we have is 3x plus 2 equal to 0. So this means that x minus 1 is equal to 0, or 3x plus 2 equal to 0. So this gives us x is equal to 1, or 3x is equal to minus 2. Therefore x is equal to minus 2 by 3. So these are the two solutions of this rational equation. Let's take a look at the next question. 3 over n minus 1 plus 2 over n is equal to 3 over 2. So in this case, again, the first denominator is n minus 1, and in this case the denominator is n. So on the left side we need to have the common denominator. So the LCM of n minus 1 and n is n times n minus 1. So let's rewrite this equation. So 3 over n minus 1. So this needs to be multiplied by n. So we'll multiply the numerator also by n, plus 2 over n times n minus 1. So the numerator also needs to be multiplied by n minus 1. And on the right side of equal to sign, we will just write 3 over 2. So now that the denominators are common, we can add the numerators. So the numerators are 3n plus 2 times n minus 1 over n into n minus 1 equal to 3 over 2. So at this point, we can group the numerator over here. So we get 3n plus 2n minus 2 over n times n minus 1. That's equal to 3 over 2. 5n minus 2 over n times n minus 1 equal to 3 over 2. So at this point we can cross multiply, and then we get 2 multiplied with 5n minus 2, and that's equal to 3 times n minus 1. This becomes 10n minus 4, and on the right side we have 3n squared minus 3n. So we can subtract 10n from both sides and add 4 on both sides. So basically we get 0 equal to 3n squared minus 13n plus 4. So we just need to solve the quadratic equation. 3n squared minus 13n plus 4 equal to 0. So we can factorize this as follows. So 3n squared minus 12n minus n plus 4 equal to 0. The greatest common factor in the first two terms will be 3n, and then we get n minus 4. The greatest common factor over here we can take as minus 1, and then we get n minus 4 inside the parenthesis. And then we take n minus 4 as the greatest common factor, multiply that with 3n minus 1, and that's equal to 0. This implies n minus 4 is equal to 0, or 3n minus 1 is equal to 0. On further simplification, that means n is equal to 4, or n is equal to 1 over 3. So these are the two values of n. So in this question, we have 8 over x squared minus 4 equal to x over x minus 2. So if you look at the denominator over here, x squared minus 4 can be factorized as x minus 2 multiplied with x plus 2. So this is based on a squared minus b squared equal to a minus b times a plus b. So x squared minus 4 is nothing but x squared minus 2 squared, and therefore we can rewrite that as x minus 2 times x plus 2. So let's rewrite the original question. We have 8 over x minus 2 times x plus 2, and that's equal to x over x minus 2. So looking at this question, one thing is clear, that we cannot have the value of x equal to 2 or the value of x equal to minus 2, because if that's the case, our denominator on the left side will become 0, and also the denominator on the right side will become 0, and therefore that's not allowed. So therefore these two values of x are not possible. So now we can cross multiply, and therefore we get 8 multiplied with x minus 2, and then that's equal to x times x minus 2 times x plus 2. So we can divide both sides by x minus 2. As you can see that we have x minus 2 as a factor on left side as well as on the right side. So let's divide both sides by x minus 2 to get rid of it. So that cancels. X minus 2 divided by x minus 2 is 1. So we have 8 equal to x times x plus 2. So let's expand the right side. So we get x squared plus 2x. We can subtract 8 from both sides, and we can rewrite this equation as x squared plus 2x minus 8 equal to 0. So let's solve this quadratic equation. We can factorize this as follows: x squared plus 4x minus 2x minus 8 equal to 0, and then we can take x as the greatest common factor in the first two terms. So this becomes x plus 4 inside the parentheses. You can take minus 2 as the greatest common factor in the next two, and that will get you x plus 4 inside the parentheses again. And therefore now we can take x plus 4 as the greatest common factor, and we get x minus 2. That's equal to 0. So therefore x plus 4 is equal to 0, or x minus 2 is equal to 0. So this will give us x is equal to minus 4 as one solution. This will give us x equal to 2. But if you remember that we cannot have x equal to 2 because that's going to make both of these denominators 0, and that's not possible. So we will reject this solution, and so the only answer will be x equal to minus 4. Let's take a look at the next question. 1 over a minus 3 plus 1 over a square minus 9, that's equal to 8 over a plus 3. So a square minus 9 over here can be rewritten as a square minus 3 square, and that will be equal to a minus 3 times a plus 3. So our question is 1 over a minus 3 plus 1 over a minus 3 times a plus 3, and that's equal to 8 over a plus 3. So looking at this question, one thing is clear, that we can never have our denominators equal to 0. So we have some restrictions on the values of a that can be used. So looking at the first part, we have a minus 3 in the denominator. So the value of a that makes a minus 3 equal to 0 is a equal to 3. So we can never have a equal to 3. Looking at the next part, we also have a plus 3 in the denominator. So a plus 3 equal to 0. That means a is equal to minus 3. So we cannot have a equal to minus 3 as the value of a. And then in the next part, we have a plus 3 as the denominator. So that also means that a cannot be equal to minus 3. So we have some restrictions on the values of a. So a cannot be equal to 3, and a cannot be equal to minus 3. So that is something that we have to keep in mind. So one thing that we can do over here, we can find the least common multiple of a minus 3 and a minus 3 times a plus 3 on the left side. So the LCM of a minus 3 and a minus 3 times a plus 3 is a minus 3 times a plus 3, right? Because if you remember the method of finding LCMs, if we write a minus 3 comma a minus 3 times a plus 3, and we draw a vertical line like this and a horizontal line like this, the only thing that's common, the only factor that is common in these two is a minus 3. So if we pull that out, we get 1 over here and a plus 3 over here. Now the only common factor between 1 and a plus 3 is 1. So therefore we find the LCM as the product of a minus 3, 1, and a plus 3, which is nothing but a minus 3 times a plus 3. So now we can rewrite our question as follows. Let me erase this vertical line. Is 1 over a minus 3, so which is this part, and then we can multiply that by a plus 3 in the denominator as well as in the numerator. The second part is 1 over a minus 3 times a plus 3, so we don't need to make any changes because we already have the denominator that we wanted, and on the right side we have 8 over a plus 3. So now that we have the same denominator on the left side, we can combine the numerators. So we will have a plus 3 plus 1, which is, I can rewrite that as Let me rewrite that as a plus 4, and then in the denominator we have a minus 3 multiplied with a plus 3, and that's equal to 8 over a plus 3. So now, as you can see, we can easily cross multiply these. We will have a plus 4 times a plus 3, and that's equal to 8 times a minus 3 times a plus 3. So because we have a plus 3 on both sides of equal to sign as a factor, we can divide both sides by a plus 3, and that cancels a plus 3 on both sides. So now we have a plus 4, which is equal to, we can distribute 8 times a minus 24, and you can subtract a from both sides and add 24 on both sides. So a minus a is 0, 4 plus 24 is 28, and that's equal to 7a, and you can cancel minus 24 with 24, that becomes 0. So 7a is equal to 28, divide both sides by 7, and that means a is equal to 4. So that's the value that will satisfy this equation.